Shall I start then?
So yes, introduce me yourself, Shriyari.
Good evening, sir. My name is Srihari. I did my BTech from JNTH Hyderabad in mechanical engineering. During my studies, I got an opportunity to intern at Sandvik Mining and Rock Technology in Patancheru. At the internship, I had learned about the production process of rotary drill bits. And during my campus placement, I got placed in L&T construction. Currently, I'm working in L&T construction as an automation engineering, and my working profile is automating the most repetitive works in the construction industry, which includes generating Excel reports or drawings from the Python code. And I believe I am a team player and I am good at time management. Uh, I am looking forward to start my career in IOCL. So thank you.
Okay. So why do you want to join IOCL?
So IOCL is one of the prestigious and one of the largest PSU, and being starting a career in the IOCL is a good opportunity. And I feel like working in IOCL makes me to explore to multiple domains, not just there I can be able to refineries business development, I can get exposure to multiple domains. And not just that, I even every PSU it can provide me a job security, which is so important in this today's market. And 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 working in the IOCL, it can give me, like as IOCL is one of the largest nation's energy provider. Like by joining IOCL, I can contribute to the nation's growth. So, and also the salaries and allowances, it could give me financial support to my family also. So with these reasons, any aspirant would be preferring to join in the IOCL. So in the same way, I would also like to join IOCL.
Okay, so what you have prepared? What you have prepared?
Technical or same HR?
Technical. Which subject?
Technical subjects, design subjects, and thermal subjects.
All, all thermal, all design.
Yes, sir.
Okay. So tell me, what is pump?
So pump is a mechanical device which is used to compress the fluid. Like from the mechanical energy will be converted into some form of pressure energy that is used to carry the fluids to higher height, like that.
Okay. So it compresses or it compresses what fluid?
It is used to increase the pressure energy.
Write down the
Like
Bernoulli's equation.
Bernoulli's equation.
And also state the assumptions and limitations of Bernoulli's equation.
Okay. Like how should I rotate the camera? I got it, sir. I got it.
You could have come via laptop.
Is it visible?
Yes, go on.
P
Right.
by rho g, V square by 2g plus y1. This is energy per unit.
Okay, write down the differential.
Energy,
Write down the differential form.
differential form. dP by rho g plus VdV by g plus dy.
Now, convert this
Again,
into continuity equation. Can you do it?
continuity equation.
Can you do it? First of all, tell me, can you do it?
Continuity equation, yes.
Yes or no?
From the.
How can you convert Bernoulli equation to continuity equation?
From, like uh, integrating, like if you do differentiation on one equation, you will get another equation. So the logic is that only, like change in momentum dmv by dt gives the work done. So from this principle, we will get that, you said, no, convert that Bernoulli to continuity.
Okay, fine. Okay, fine. When you guys rotate the camera,
Okay.
state the assumptions and limitations of Bernoulli equation.
Like assumption is the fluid is to be viscid and flow should be steady and flow should be incompressible. And if I write the equation between 2 points of a straight line, like these are enough. But if I write this equation between any 2 points, like flow should be irrotational too.
Now tell me, why do you use these equations like Bernoulli equation and continuity equation? Why do you use?
Bernoulli equation, continuity equation.
Hmm. Why do you use?
Like uh,
What is the use of
like
it?
like at one location, if you know the pressure and velocity, like at the other location, we could know that like what maximum pressure, even if we change the cross section area, like with that we can design that pipe material with the like how much stresses can be that point. We can use Bernoulli's equation. Flow is from 1 to 2.
Yes, sir, go
Like
on.
if I assume that if I assume the flow direction is from 1 to 2, then if I apply Bernoulli's principle between 1 and 2 points, then head losses I will be getting as positive. Like otherwise, if it is ideal fluid, we will get as zero. In that case, also we can use the Bernoulli's equation, like to know the flow direction. I mean to say.
Okay, fine, great. Now, just tell me, like in industries, right? Okay,
Yes,
you must have seen the. Have you seen pressure gauge anywhere?
pressure gauge. But as of now, I don't know. Pressure
Pressure gauge,
gauge.
not in industry, but anywhere. Have you seen pressure gauge?
Kind of things. The manometer, like this, those things only I have seen.
Have you ever filled the air in tire?
Ah, yes, sir.
So there you must have seen the pressure gauge.
It's a pressure gauge. Yes, sir.
Yes, have you seen that? Okay,
Yes, sir.
okay. So fine. Now you must be knowing that embanking of road is there. So why do we do the embanking of roads?
Like embankment means like the slope will be made no sir. That we call as embankment because when we make a circle, like for a system of some mass, when it is rotating around a circular point, it will be some centrifugal force will be generated outwards, radially outwards. So like if we do not embank that, if we do not increase the slope of that road, then we may fall down, like the bike may slip or in that way. So if you could increase the slope of that road, the gravitational force we know as a W cos theta, W sin theta. So that W sin theta could somewhat tackle that centrifugal force. In an inclined plane, if we assume W weight is acting downwards, W cos theta will be perpendicular to the inclined plane. W sin theta will be along the inclined plane. So the W sin theta will be tackling that.
Okay. One question and last question I would be asking you. Okay. There are
Mm.
loading. What is the problem? Okay. Sorry guys for the interruption. Okay. Internet connectivity issue. Yes. Now it's visible, right? Okay. So the
Yes.
first question I will be asking you. Okay.
Mm,
This is the plane. Okay. And this is one of
okay.
the, okay. There is one block. Okay. With mass
Mm,
M. Here also there
mm,
is a block with mass M.
okay.
Okay. Now
Yes.
the fluid is there with viscosity mu. Here also there is
Mm,
some viscosity mu. Okay.
mm, mm.
But the thing is, okay, first of all, tell me, ki, which will, okay, uh, okay. I want to move the block up till 10 meter. Okay, which will move easily.
Like 10 meters perpendicular to the ground, you want to move it.
I want to move the block 10 meter only. Okay,
Mm.
like this block will be moving in this direction, and this block will be moving obviously in this direction, right?
Yes. Which will be moving easily.
Which will be moving okay
Okay.
in this direction. Tell.
So the one with the inclined plane, the one with the inclined plane, there the mg sin theta also helps us in moving that block. But in the horizontal one, like only our force is responsible for moving. Along with that, we know that in the opposite direction, that frictional force, the viscous force will be acting here also.
Okay, now tell me like
Yes.
here what are the forces? Okay, like which forces are responsible? What are the forces responsible?
Responsible for the motion, or what
Yes,
are the
responsible
forces
for the
more
motion.
responsible for the motion? In the first inclined plane, can I draw it a little bit? Uh, like here, here. If it assume this as theta, this is mg cos theta, and this is mg sin theta.
Okay,
So now, but in the opposite direction, we know it is a viscous force. Viscous force is equals to tau into area. Tau into area. Tau is equals to mu into, if I assume linear velocity profile, v by y into area. And here, so the forces acting on the inclined plane will be mg sin theta minus mu into v by that y into that area. So, but in that the second case, our horizontal force F will be acting on the positive x, and in the backward direction, like in the opposite direction, the same viscous force will be coming, sir. And normal reaction will be towards perpendicular to that contact surface, and weight will be acting perpendicular downwards. So these are the forces that will be acting on these bodies.
okay, fine,
Mm.
great. So yes, Srihari, fine interview, not a problem. Okay, it was a good interview. Means I don't think so. Like in PI, you will be getting out. Okay, but try to improvise because in PI it is uncertain. Okay, the questions are infinite. The questions can be asked from any segment, any sector. Okay, so be prepared. Okay, like they are not going to ask you some very conceptual question if you have faced, I mean to say, the Bark and NPCL interview, but the questions will be one liner. Okay, what is incompressibility? What is compressible flow? What is pumps? What is stress strain curve? Right? This is the only thing. Okay, they are going to ask you. So all the best for your interview. Okay,
Okay,
let's.
so thank you.